All right, we're re-recording, and so so one thing I will do is I will, because I need to share the screen here and do some stuff, I'm going to go ahead and turn off my camera as we share the Java code that we'll be working with for these examples. So a couple of examples I put up here. One is, all right, so if we go back and look at the simple circle, let's see, simple circle. I don't see simple circle in here. It must be. Oh, that's right, because we had it as a second class. Yeah, that's right, because one of the things I wanted to point out, I don't remember right now if I pointed this out last week or not, but the only class in a in a Java file, there's only one public class, and that's the name of the file, but we can have other classes as well. Right? We don't have to have only one class in the Java file. It's just that the one that's public is the same as the file name. Okay, so let's. Here, notice we have another class called Simple Circle. If we try to make it public, we try to compile it, we should get a compiler error saying, oh, nope, nope. Simple Circle is public. It must be in a file called Simple Circle.java. Okay, so we can't have another public class that also. So we can't have another public class that also exists in this class file. Okay, in this. Okay, but notice that the radius here is it's not a private data field, right? We didn't put any modifiers on any of our data fields or yeah. So here we run this, and we're going to create 3 circle objects. Show you how that works. Okay. So circle object 1, right? It has a radius of 1. The default value, right? Because we had the constructor here sets the default radius value of 1. Okay. So now it displays the area here. We can create another circle called circle 2. This time we call the constructor with a parameter, and we set the radius based on that. And now we have a circle 2. We have 2 circles, one with a radius of 1, one with a radius of 25, right? Okay. We can create a third with a specific area. Oh, I didn't mean to jump in. All right. Now notice here also we can set the radius value using just the dot notation, directly accessing the radius variable value inside of there. So notice it changes it there. Okay. So now there is that. Okay. But the question that I was asking, so the reason why we were talking about this with private data fields is what would happen if I said I want to set this to -1? Okay, so a radius of -1. Compiler error? Nope. Okay. Will I get a runtime error? No. Right? Yeah. Okay. Will I get a runtime error? No. Okay. Will I get a runtime error? No. Right? Yeah. Okay. Will I get a runtime error? No. Right? Yeah. Okay. Will I get a runtime error? No. Right? Yeah. Okay. Will I get a runtime error? No. Right? Yeah. Okay. Will I get a runtime error? No. Right? Yeah. What's the area? What's the area of a circle of radius -1? Watuan says -3.14. Haidar says logic error. Any other answers? Omer Lutfi says, yeah. I will say though, it's not -3.14. Right? Because the area is radius squared, right? Radius times radius. So since a negative times a negative is a positive number, but it is still a logical error in the sense that what is a circle of radius -1? Is that like circle made from dark matter? Is that the circle inside of a black hole? Is that, you know, it's like, it doesn't really exist mathematically, does it? It's not a real object, right? So this is why, and let me change this back to 100 so that it doesn't show up there. Okay. But this is why we create our objects, our classes with private members. Okay. Private, that way we control what people can set those values to. Okay. So now when we have a set radius, now we can check, did they enter a value? Now I don't know what a circle of radius 0 is. I mean, I guess that's a point, right? A point in space, all right? But I guess that's allowing that to happen, right? So if the radius value that's passed is less than 0, then we say, nope, we'll just make it 0. Okay. Otherwise, if the value is greater than or equal to 0, we will use that new radius value to change it. Okay. Now I want you to notice that this is slightly different than the example that was shown in the slides, in that the example shown in the slides for the set radius method used this keyword, right? Also notice that this changes color. That's because that's a keyword, right? There's a Java keyword. Okay. This is a different way to do the same thing. Okay. So the new radius, if it's a valid value, which we can define, right? We set it to be that value. If it's invalid, we've set it to be 0. Okay. Now, do we know if that's correct as far as what the user or the customer wanted? We don't know, right? I mean, it is a possible way to do that. What if they said no? What if they said if the new radius is less than 0, we just want to use the old radius value, whatever it was. Okay. Well, a couple of different ways we could do that. We could do like that. Right, now that what that says is if the radius is valid, if the new radius value is valid, set it to that. Otherwise, just use the old value. Okay. We could also do this. We could also have done it this way. This does the same thing. Notice that if the new radius value is valid, we set it to that new radius value. Otherwise, we don't do anything. We leave it alone. We don't change it. Okay. Both of those are acceptable ways to do that. Okay. Actually, you know what? Yeah. to what they had before. Those of you who watch this later, you'll know. Okay. So by making our data field private and using get and set methods, right, that's how we're able to access those values. Okay, so we're going to test it now. Okay, so here we're going to check and see what happens. So now circle with private data fields. We create a circle that has radius 5. And we can see what the area of that circle is. And now we're going to change the radius by 10%, increase it by 10%. So this would be as if we had said my circle dot radius equals my circle dot radius times 1.1, right? If the radius were a public data field, if we had access to it directly, then we could have done this. But because it's not a public data field, we have to get the value. We can multiply it by a factor, 1.1, and then we can set the radius to that new value. Okay. So here, if we see what's going to happen. So what's the new value going to be? What's the new radius value going to be? Question mark, what question mark? Denise, I'm not sure I know what you're talking about. What question mark? Let's continue on. Yeah, yeah, but where? I don't see that in this file. That's what I'm confused by. Oh, you're talking about this here, right? That's the other way to do an if statement. We talked about that in 101. So if you need to go back and review conditionals from the 101 course, that's a way that there's a special word for it. It's not a ternary, right? Ternary operator, right? That is a different way to do an if statement. Okay. So here, so we're going to set the value to the new value, 5.5. All right. And now our circle now has the radius 5.5. Again, this is so that we don't allow a radius to be negative. So what would happen if we tried to make it negative? Okay, what would happen? Compiler error? Yes, no? Compiler error? Three, two, one. Nope, compile's fine. Okay. Let's start running it. Okay, runtime error. What's a circle with a negative radius? That doesn't make any sense. What's let's see. Pass it negative 1.1. We get up. Nope, it's fine. It got to the next line. Wait. So what's the area of a circle Area will be 0. Why will area be 0? Zero. Why will area be 0? Ismail? Yeah, we made the radius 0 if we pass a negative value, right? So the radius is 0, therefore the area is 0, right? Because what we did was we controlled. Here we said if someone passes us a radius that's negative, we're going to make that radius 0 instead. All right? Okay. Let's talk about 2 more things, and let's do the static members and then do one more thing that I want to show you guys. And then we will call it a day. Okay, so the static members is we have this static number of objects. Okay. Now, what happens is that we can use that to keep a track of how many of a certain object we've created. So here we have the number of objects. It starts with 0, and then each time we call the constructor, anytime we construct a new circle, we add 1 to the number of objects. Okay, so we're saying construct a new circle, construct a new circle, we're going to add 1 to the number of objects. All right. We can get the number of objects to tell me how many there are, and also the whole get area thing is still staying there. Okay. Okay. So let's walk through what's going on here. Okay. So before creating objects, we haven't created any circles yet. How many circles are there? If we haven't created any circles. We haven't created any circles. How many are there? Yeah, good. 0. Number of circle objects is 0. Perfect. Okay. Now we create a new circle object, C1. Point it to use C1 as the variable to point it to. We created C1. The radius is C1 is the radius is 1, and the number of circle objects we've created is 1. Right? Okay. C2, its radius is 5. Okay. So we created now a circle with radius 1 and a circle with radius 5. How many circles are there? Number of objects. How many circle objects are there? Yeah, 2. It's highlighted on the screen. All right. Okay. Now we changed the radius to 9. Okay, I'm going to hide this because I don't want to give it away. Okay, so now we created a circle with radius 1, we created a circle with radius 5, and now we have a circle with radius 9. How many circles are there? Good. Nobody's tricking you guys, right? Because it's not that we created a third circle with radius 9. We only modified C1, right? Sorry, yeah, we only modified C1. We modified the radius of one of the circles. Okay, number of circle objects to C2 radius is 5, and the number of circle objects is 2. Okay. All right, so let's modify this a little bit and have some fun. All right, let's see. C1 has radius 9, so let's make it radius 9. Okay. Okay, so let's get down here. So we're creating. So we have C1. So we created a circle with radius 1. We created a circle with radius 5. We modified the circle with radius 9. Then C1 points to a circle with radius of 9, and we did that 4 more times. Okay. How many circle objects are there now? Radius 1, we created a new circle with radius 1. We created a new circle with radius 5. And then we ran this line 4 times. 2, right? C1 and C2. Oh, what Conbert comes in saying 6. That's very different from the other answers. Let's see. Jury says 6. What? But there's only C1 and C2. Remember, the number of circle objects, it gets incremented. Add 1 to it every time a new circle is created. So even though we created the same new circle multiple times, let me go back and show you as we walk through it when we get to those lines specifically. Okay. Notice this here, the object reference 192. Okay. Because when we do this, watch, it's going to change. 218. It's going to change again. 219. It's going to change again. 220. Every time it does this, it's creating a new circle object. It's not the same circle as it was before. Okay? Okay. All right. So let's do something slightly different. Instead of creating a new circle object each time, let's do okay. File that. Wait. It's circle with static members. Last names are important. Okay, Metop or Sueda? Which would be better for me to call you by? Because if you're talking about the old one, before I move on to this, let me address that question. There were 6 objects in memory created. So there was only 2 reference variables. So remember, this is kind of like, oh, I don't have whiteboard on this. I'm gonna have to download it. Let's do it this way. Let me show you it this way. Remember when we talked about this? Each time we created a new object, C1 pointed to a new object in memory out here. So when we created C1 equals new, C1 equals a new circle, and we created this and did this here. Then we did it again. Okay, then it gets rid of this and points here now. Then we did it again. Okay, then it gets rid of this and it points here now. Right? So all these objects still exist, right? This one exists, this one exists, this one exists. Right? Now, when the garbage collector comes around and gets rid of these old objects, we don't know. Right? But those objects were created and they were distinct. They were separate. They were not the same as the original object. Okay. The reference variable just changed what it was pointing at, but all of those objects were created. Okay. And remember, this variable, Okay, this variable number of objects does not actually count the number of circle objects in memory. What it does is it counts how many times the constructor for that was called. All right, that's slightly different. It doesn't actually go out into memory and say, okay, let me find all the circle objects and figure out how many there are. What it does is it says how many times did we call this constructor at some point. Okay. All right. So make sure you let me know if it's Metop or Sueda, which name do you go by? All right. Okay. So back to here. Right. You can only C1 can only point to the last circle that it pointed at. Right. And that comes back to what we talked about earlier about the garbage collector. About that when the virtual machine, the JVM, when it sees that there are objects that are no longer accessible, it cleans them up. Okay, so those objects might not exist in memory anymore, but that number of objects was called, so the constructor was called, and so that's why that number got increased. Okay, so let's move on to this. Okay, let's see. So let's move on. So here we're going to create a new circle object, right? C1, radius of 1. We're going to create C2, radius of 5. We're going to change the radius on C1. That means 2 circles. Now we're going to create C3 and point it to the circle that C1 points at. We're going to create C4 and we're going to point it there. We're going to create C5. We're going to point it there. We're going to create C6. We're going to point it there. All right. How many? How many circles are there? Conberg says 2, but there's a 6 there, and a 5, and a 4. Yeah, sometimes I don't like to trick you guys on exams or quizzes, but I might trick you in the class sometimes. Yuck. Yeah. So the number of objects, Conberg, you're right, is 2. And the reason why is, again, it's because how many times was the constructor called? Remember, if you look here, all 5 of these point to the same object in memory. Right? It's the same object. We didn't create a new circle. There was no new circle created. It was how many times. It was how many times was the new keyword used. How many times did we construct a new circle? The only thing this did was it said, give me a memory location and point it to an object that already exists. Okay. So make sure you understand why this is, why it's 2 and not 6, or why it's 2 but not 5, or why it's 2 but not whatever else you might have thought it could have been. All right. Because we created 2 new circles. 2 times the new keyword was called with a constructor, right? Right. These lines did not create any new circles. They only pointed variables, reference variables, to existing circles. Okay. All right. All right. One more thing we want to do, and then we can call it a day. I wanted to show you guys some different ways of doing the same thing. Okay. All right. All right. Okay. So we're going to have an integer variable called myInt. Okay. Now, let's say that what we want to do is we want to have a default value of 1 for myInt, but we want to be able to set it also because we made it private because remember we talked about this. We make our variables private. We make our what are they called? Methods public, right? Okay, so we could say my int equals 1. Okay, a default constructor that if there's no parameter passed, we give it a default value. Okay. We could also create an overloaded constructor. We talked about this, right? With this keyword, right? All right. Now this way, this is saying take a value called my int, set it based upon what the parameter is passed is, right? Default value is 1, right? So now let me go ahead and do these two. Public int get my int. And we just do this again. All right. Okay. So this is one way that we could have a default value of 1, and we can pass a value any other way. Okay. All right. Notice that this line and this line is the same. You know what we could do? You just do it that way. All right. Now, I would say be cautious with this because, say, for example, we wanted to allow no negative values. Sorry. Wanted to allow no negative values, right? What would happen here? What would be the default value? What do you guys think? What would be the default value if we did it this way? Let's create a new. While you guys think about it, I'm going to create a new one to test it. Okay. Oh, the test file. Oh, there is already. Okay. All right, so let's go back to the way it was before. Let's do this here. Actually, Okay. Let's do set. All right, so when we run this, okay, what's going to display here? What's the value of my get my int? One, right? Because it was the default value, right? Because we called the no-arg constructor, right? We called the no-arg constructor and set it to 1. Okay. Now what's the value? Yep, still 1. Okay. Now, what if we change this, like I said, if we pass it a value, say, okay, set my, set my int. Now I'm going to pass it here. Okay. So it's still going to work out to be the same, I think. No. This was what I was. So if we did it this way, oh. Okay. So let's talk through this one. So those are right with the 1 and the 1. Okay. Now, what's the value of my int now? Okay. And somebody says 0. Somebody says 1. Nobody's saying -1 though, I see so far. Okay, let's see. Oh, 0. I never set my int to 0. How did that happen? Remember, the instance variable has a default value of 0 unless we give it a value. Okay, so this was not what we wanted to have, right? So if we change this back to, okay, forget this, we're going to do it this way. This should fix it, right? Okay. Now what's it going to be? It should be 1 now, right? -1, how's that possible? We just set it straight, right? Okay. So that's why I was saying be careful with that, okay? So another way you can do this to set a default value is instead of setting it inside of the constructor, is set it out here, right? And then that way, you don't set it in the constructor, right? Now, this does the same thing. Forget this for a second. Let's say we don't care about checking values for now. Yeah, okay. So now the default value is still 1, right? But I think now I changed it to where I allow negative numbers. Yeah. Okay, so let's. Oh, the reason why I did that way is because now actually, because we set the default value out here, if we have some type of check in the set my, we can use that here now. Okay. So now this will use the default value of 1. So 1, 1, and then even when we call it like this, we get 1. Okay. All right. That's everything there. Okay. A couple more things. Okay. The reason why I wanted to get to this also was the many ways was how to also even do this stuff here with the this keyword. Remember, I said during the lecture time, I said, I don't usually use the this keyword. Okay. It's just it's part of my fingerprint. All right. We talked last week about every programmer has their own fingerprint of how that they code. Right. So the ways that I do this, the way that I would do this is my method, instead of having the this keyword, is I would say like this. So now the way that this works is I'm making sure that for me as the reader, I know this is the n value, so the variable that I'm trying to change. The n value, all right. I check the n value and then I set my instance variable based upon the value that I passed in to the method. Okay. So which one of these? This one or this one? Which one of these is right? The right way to do it? Yeah, they both operate the same way, right? I think probably the reason why I choose this one is one, it was the one that I learned when I was in school. And I think also it's because this way there's no variables with the same name in the same space, right? So there's no, this has a variable that has the same name as this one, right? Which for me can sometimes get confusing. All right, but both work, both are fine. Okay, so, but let me, because then it won't compile if I leave it like that. So we can set a default value by setting it outside as part of the declaration and then not changing it as part of the constructor. We can set a value inside of the constructor using just the do that. We can, in certain circumstances, but we need to be cautious, call the set my int method as part of the constructor. For that, it's called the set method as part of the constructor. We can also do this. Default value like this. This way, if we call it with no value, no parameter to the constructor, it calls the other constructor, right, with that value, with that default value. So that's 3 different ways right there that I showed you guys how to do this, right? So you can set the value. You could say equals value. You can do it this way. You could do it this way. You could set the value out here and have no code at all there. All three of those will work pretty much the same. Functionally, there are some differences in how it executes, but as far as what we as the user see, those will all be the same. Okay, but I do want to end on one reclam. Okay, because that runs. Okay, because some of you might be tempted to say, okay, well, let me answer this question before I end on the reclam. What is the difference between public method in a class and nothing? Okay, so nothing is what's called the default visibility. We will talk, that has to do with, it was in the slides here, has to do with, let me pull it up real quick and then I'll do this. Okay, so it has to do with this. Public means anyone can see it. Nothing means it's called the default visibility modifier, means that classes within the same package can see it. I don't really do a lot with packaging, and so that's why I didn't discuss it in depth. But notice that class C2 within the same package can have access to that variable or that method, but classes outside of that package do not get access to it. So that's what the none is. And then there is one other that there exists that's called protected, where it has to do with inheritance. And when we get to the class on inheritance, we'll talk about that one too. So there's actually four visibility modifiers: public, default, protected, and private. And we will talk about the protected one when we get there. Okay, but like I said, I don't do a lot with packaging. Professors that have taught this class in the past have focused more on that and used that as exam questions and stuff. It's not really something you'll do a lot of in this course, and so that's why I don't focus on it a lot, but in more advanced Java programming, you would get into that. But that's a good question. Okay. Okay, so here's my reclam. Okay, so some of you might be tempted. One line data field. Oh, you mean like my int here? No, because like if I understand you correctly, a constructor can have more than one. So like, for example, let's say there were two integers, or a double. First line of the many ways method, is that what you mean? Ooh, nope, that's not right. So like here, we could do this with 1 and 0.0 like that. Okay, and so when this is executed, it would call this here. Okay, is that your question? Is that what you meant by this keyword? Because this could call this one here if I only had like that right there. This one would call this constructor. The way that I had it a second ago, this version would call this constructor. Okay. I hope that answers your question. Okay, so we're almost out of time, so let me go ahead and get to, as I said, the reclam, right? So this is what we had a second ago, right? I'll leave that there for fun. Okay, so some of you might be tempted. Let me make sure this still compiles. Let me sure this makes sure this still compiles and runs. Okay, good. Some of you might be tempted to say this method is pointless. Why do I have this here? There's no code in it. There's nothing going on. It doesn't do anything. Why do I need it? I'm going to delete it. Okay. I'm going to save it and compile it. Great. I'm going to submit this. I'm going to send this to my Hoja. I'm going to send this to Berk. He's going to test it and everything's going to be great. And then Berk gets it and he goes to compile it and he gets a compiler error. What? Why? That code didn't do anything. It was blank. It was empty. It was pointless. Why was it there? That's something we'll learn in a future week. All right, so that's my reclam is what is going on? So don't answer in the chat. If you're starting to type a message, just don't type it, just don't enter it, okay? Because we're gonna find out the reason for why that just happened in a future week, okay? So hold on to that. Hold on to that moment of why did it do that, okay? And we'll get to that later. All right, have a good afternoon. I'll see you guys tomorrow afternoon as well, and we'll continue into the next section about how to think in terms of objects. All right. Any questions before we end the call? Any final last words or questions? All right. Well, goodbye to you also, Emre Kamal, and we will see each other tomorrow at 1:30.